Hello! Today we're going to work on an inventory thing with some coins to pick up, kind of Mario style. So if you like the sound of that, let's do it. Okay, first things first, we are here in the editor. I've got a lovely bunch of coin textures here. I pulled in a little 48 by 16 coin thing. Extracted the sprites, and I made a little flip book of the coin. So that is the assets we're going to use. You can figure out how to make that. We now need to make a player controller class. So that's what I'm going to do first, is a hopper player controller. I'm going to stick it into public and core and create the class. Okay, a lot of this is going to be a bunch of coding, so stick with me. You're no longer going to see that fancy little blue thing, also because the way that OBS captures a program, apparently it does not grab the mouse highlights, so ignore that. Okay, first things first, make a public section. We're going to create our standard little constructor that we're not going to do anything with. And then we need to override begin play. So that's there. Now let's make some inventory related functions. Make a big old comment block here. Okay, inventory data is going to be a map. So we're going to do a U property of visible anywhere so we can see it, blueprint read only so we can access it, and we'll stick it into an inventory category. This is a T map of U hopper item, which we have not made yet, and F hopper item data, which we have not made yet. Call it inventory data. Right. So why don't we create those things so that they actually exist? All right, we are in the hopper data header. Let's go to the bottom, and we're going to make a ustruct called blueprint type and struct hopper API. This is F hopper item data. You know what? I just realized this should probably be hopper API as well. This should be hopper API. I don't know about enums. Should enums be hopper API? I don't know. I'll look that up later. Anyway, let's continue. Once you have that made, we're going to do a generated body as usual in there. Let's make a constructor so that we know how to make one of these things. It's going to receive an item count it's going to make an item count by default, and it's going to make an item level by default, and empty brackets. We don't know what item count and item level are yet, so let's just toss those in. It's a int 32 item count and an int 32 item level. They sound exactly what they are. We're going to give those U properties as well, so edit anywhere, blueprint, read write, category equals item. Copy that, give it to the item level as well. I'm going to dump a quick comment in there. These can never be below 1, which is why our default constructor here, if you just make an F hopper item data, it will set those to 1. Now we need to have another constructor in case we want to manually set those. So an in item count comes in, and a const int 32 in item level comes in. This sets our item count to the in item count, and it sets our item level, to the in item level. And then open close brackets. All right, so we're gonna do some operator overloads. First of all, you know what? I'm just gonna copy these and paste them over in here because we don't need to run through all of them. So this is just comparing. This is our equality operators. So we check item count and item level, and we see, are they the same as the one on the right side? If so, we return a Boolean of false or true. Same thing here. If the pointers, or rather the addresses, if our address, our dereferenced this, is equal to the reference of the other, then we know that we are, with a not sign, we know we're not equal. So that's what's going on there. Next we need to do an isValid, and our isValid just checks if our item count is greater than 0. And then we need to update our item data. So I'm going to write this one out. So update item data. Another little thing that OBS does when you're just capturing a window is you don't see the drop downs, the little drop downs of writers. So if things just pop up, it's because I'm hitting tab and it's excuse me, grabbing those things from a drop down. All right, so we're receiving an other, so an item data, we're receiving a max count, and we're receiving a max level. If our max count is less than or equal to 0, our max count is going to be a fancy maximum of an int 32. That's a whatever the max of an int 32 is. We can go check that. There you go. It is this guy right here, this big giant number. So maximum value. All right, so if our max level is also less than or equal to 0, we're going to do the same thing. Max level equals max of an int 32 as well. Now, our item count of our data class here is math clamp the item count plus the other dot item count 1 max count. So we are clamping whatever is coming in from this other, right? So our current item count plus the others, and we're making sure that we don't go above or below what an int 32 can be. So that's what's happening there. Now we're going to do the same thing with an item level. So we're going to clamp again the other dot item level, and we're not adding anything here. We're just taking the item level from the other thing. We're clamping between 1 and the maximum value that an int 32 can possibly be. All right, so that's how we update. Where is it? That's how we update item data. All right, now we need to have some delegates. I'm going to just copy and paste these as well. So we haven't made the hopper item yet, so that's going to be a little squiggly there. So we're going to do that next. But this is going to be what we call and broadcast on anytime we've modified our inventory, right? So that things know when they need to call other functions. Okay, so there's our item data. That's what an item holds. Let's go ahead and make a hopper item. This will be a primary data asset. This is something that an asset manager uses, and we're not going to make the asset manager in this video. We will later, and then I might go over that more. So what am I going to do? Let me check here. I'm going to make a new folder. Directory. I don't think you see any of those drop downs, but in the core folder, I'm going to make an items folder. And is that in the right place? It didn't do it. Put it in the core. Thank you. All right, in items, we're going to do a new file. Again, you don't see this popping up. I'm going to name it as hopperitem.h. Now you can see it over there. Ta-da! All right, same thing. Under core in the private area, I'm going to do a directory called items as well in the private area. All right, now add a file called hopperitem.cpp in that one. Okay, here we are. I'm going to drop in the usual top stuff. We now need to do an include of core/hopper.h. Actually, one real fast thing in our hopper.h, go ahead and include core/hopper data. That way we just, this is going to be like our main header that we just include in stuff, so that when we include this, we get the data. All right, so include What do we want? We need the engine data asset, and we're going to do an include of styling, slate brush. Whoop, I misspelled that. Styling spell. Come on. Slate brush. So if we want to have a picture associated with this item eventually. And we got to do our hopper item.generated.h, because we're going to have to right click and regenerate project files since we've added this in manually. Alright, so let's forward declare real fast because we're going to need this, our gameplay ability, in case that this item modifies an ability. Alright, uClass, it's an abstract, we don't make this. This is a blueprint type. This is just a parent, right? Things come off of this, so we're not going to make it anywhere in blueprints. Hopper item, public U primary data asset. That's what this inherits from, so that it has primary asset types, IDs, that kind of stuff, so we don't have to create a whole hierarchy of parent and child classes. There is something in Unreal Engine called the Asset Manager that does all of this kind of stuff for us, and it's a lot more complicated, and I will save all of that for a different video. Generated body. Whoa, what did I do? Nope, I don't want all of that crap. Get rid of it. Generated body, there we go. Public section, our constructor for a hopper item is going to have a price of 0 by default, a max count of 1 by default, a max level of 1 by default, and an ability level of 1 by default. And then your open close brackets. We don't know what those are yet. We're going to make them. But first, we need a U property. Visible anywhere so we can see it. Blueprint read only so we can access it. Category is going to be of type item, or the word item rather. We're going to make a primary asset type. This is what the asset manager and the data is going to look at. So this is an item type. So we know this is an item, right? So we could have weapon type, armor type, clothing type, etc. once we make children of this hopper item. This is the parent. Alright, we want a U property of edit anywhere. This is where this changes. So blueprint read only so we can access it. Category is item. This is an F text item name. This is the name of whatever child we make. U property, the next one is also an edit anywhere and a blueprint read only. Category is item. I could have just copied that, but I need to practice typing apparently. F text, this is our item description. So we can describe whatever we have in our inventory. Alright, another edit anywhere. This time I am going to just copy and paste. This is our slate, F slate brush item icon. That's if we want to give it a picture. Should we build a slot type system or an inventory? We're just going to collect coins, so we're not going to use that currently. This also we're not going to use, but we're going to make it just in case someday we want to use it. It is the same header here. This is our int32 price. Now we need to have, oh, right. If it ever becomes a potion, this is a pure, blueprint pure, category equals item. This is a function, bool, is it consumable? That's how you spell it, yep, const. So that's how we find out, can we drink this thing? Or eat it. This is an int32 max count. Same header again, this is the int32 max level. You can see up here these are turning red because we're finally adding these in. Same thing, this I will change the category because this makes sense. This is under abilities and this is going to be a T subclass of our U hopper gameplay ability. There's where the forward declaration comes into play. This is a granted ability in case this item gives us an ability. Let's say it's a gigantic battle axe, and we want to have a whirlwind attack or something. There you go. This is the last U property of edit anywhere. It is the same as this guy, so there you go. And this is our ability level from above. Boom. Alright, so now our constructor's all happy. There's two final things that are necessary for a primary asset, primary data asset type, and that is a U function, blueprint callable. Category, we're going to stick it into item again. This is going to return an F string. This is get identifier string const. And then we need to have an override of get primary asset ID. There it is. This is necessary for all primary assets to grab the asset ID, identifier string also. So I'm going to dump in some comments real fast. I'll probably fast forward through this. Okay, we are commented completely except for that. There we go. Now we're commented. Let's go ahead and make the implementation. Drop in our little boilerplate. We now want to have our bool U hopper item. This is our is consumable. If our max count is less than or equal to 0, return true. Otherwise, return false. I don't quite know. That might be a remnant of the action RPG. As I modify this game, is consumable probably will change as well, because that doesn't make sense. You could have 5 potions, right? I think the action RPG, you can only hold 1 potion at a time, so that makes sense that it doesn't have a max count. F string U hopper item get identifier string. This returns get primary asset ID to string. So it's just going to convert this thing. F primary asset ID U hopper item get primary asset ID. So this is the function that is calling. It returns the F primary asset ID. We pass in the item type, which is of the off the child type will be established, and then get the F name. And I'm going to just toss in these comments as well. Okay, that is our item type. That is our primary data asset that we will be creating all of our items off of. So there's going to be, let's make ourselves an item. So we're going to add another file here, and we're going to call it hopper token item.h. This will not have any implementation. This is just a hopper item. Here's our top boilerplate stuff. We're going to throw in these includes, and this is going to be our native base class for tokens and currency, and this should be blueprinted. All right, it is a U class. It is in our hopper API. That is not how we do it. Hopper token item is what this will be called, and it inherits off of our U hopper item. Generated body and a public section. We just need, there we go. All we need is this guy, a constructor, where we say our item type. We do need an asset manager. Is a token item type, so we will be making an asset manager today. And a max count equals 0, so it's infinite. That's where that comes from. Okay, so here we have an if it's equal to 0, it's infinite, so it is consumable. Whatever. Okay. Let's make the asset manager. Why not? We need to have that. apparently. So here we go. We're not going to use this. This is just where we establish this token item type. But otherwise, we're not going to call it or do anything with it in this video. So under core, we're going to add a new file. This will be called our hopper asset manager.h. And then under core, the private core, we're going to add, not a directory, we're going to add another file called hopper asset manager.cpp. Okay. Hopper manager.h. The top stuff and the includes are those. We want to forward declare our hopper item, and uClass class hopper API, and this will be our hopper asset manager. Public, it is extending the U asset manager that comes with Unreal Engine generated body. Whoops. Public, we need to have a constructor, asset manager, constructor, doesn't do anything. Then we need to override the start initial loading. We're going to have, this is where we have our static types for items. So static const f primary asset type token item type. That's where that's going to come from. So over in token item, we go back over to that and we include, come on, core hopper asset manager. Now we have that. Okay. Do I need to make any of the other stuff yet? Why not? Okay, this one right here just returns the current asset manager object, just in case we use this. I don't think we do. I'm just going to toss it in. However, it returns a reference to this. It is a singleton. There's only one of these that ever exists, and you get it a reference by calling get off of it, off the world or whatever. Okay, over in the implementation, let's go over there. Toss these up at the top. And we need to initialize that static variable. So when you have a static variable, you initialize it like this in the implementation file. So it's a const because it never changes. It is of the type f primary asset type, as we said over here. And this is saying that this variable exists and is scoped in the asset manager right there. And then we're initializing it with an f name, or rather text, which will be implicitly converted to an f name token, which we can see if we actually go to f primary asset type, and we have this guy right here. This is the constructor that we're calling right there. It just takes an f name in. So it's making a new f primary asset type of named token item type. So that's what's going on there. And we're going to throw in this implementation for get. We're just grabbing the asset manager off the engine. We're casting it to our hopper asset manager type, naming it this. It's a pointer. If we successfully have this, we're returning dereferenced this, so the real actual reference to the asset manager as the singleton. If we are not able to, if this is a null pointer, it means we did not set the asset manager in the default engine.ini, which I will do in a second. And we're going to return this, but it should never, this should not happen. I don't know, it never calls this, whatever. Okay, so default engine.ini, just real fast. This is how you set your asset manager. Under script engine.engine, you just go like so. Asset manager class name, script /hopper.asset manager. Let's see. Oh, we need the initial loading. So initial loading calls the super and then runs that guy. Get init global data. Okay. Don't worry about that. I just wanted to throw that together so that we can have this item type variable within our token item, because that's important. Okay, one more thing that we need to make, and that is our hopper inventory interface, right? We need to be able to call some of this stuff. So there's things we need to do. I'm gonna make a new directory called interfaces. Interfaces are cool. So this is going to be called hopper inventory interface. Again, you can't see the pop-up. Interfaces allow us to implement functions, but if we call the interface function, if the thing has the function, so it's a promise. It's a promise that when we extend this, that those functions will be implemented in the class. So this is a U interface, minimal API. This is what you put at the top. Cannot implement interface blueprint. This is just C++. Class UHopper inventory interface. It is a public and it extends the U interface, and we just put generated body in here. So that's the thing. That's that. And then below, what you do is you do the UHopper API hopper inventory interface and generated body, and this is where you put the functions down in here. So I'm gonna stick that right there. Item slots we're not worrying about. I just stole this straight from an Action RPG project. But what we're going to do is we need to have a function that returns the map of items to data. We need a, let's see, gets the delegate for inventory item changes, and gets the delegate for when the inventory loads. So these are the delegates. This is what we're calling when things happen. So the first one is going to be a virtual const, and it returns the tmap of our UHopper item pointers and our fhopper item data reference, and it's called get inventory data equals 0, right? Oh, it is a const. So this is it returns a const tmap, and the function itself is const. So UHopper item is squiggled right here. If we go to hopper here, I want hopper data to have that information. And as you can see, it's still squiggled here. So what I'm gonna do up here is forward declare hopper item, so that when we include, it passes down here, so it's forward declared. So we don't need to worry about that. Okay, the next function we want is virtual f on inventory item changed native reference. And this is going to get the inventory item changed delegate equals 0. And then we want a virtual f on inventory loaded native reference get inventory loaded delegate equals 0. Those return our delegates so that we can call things when things change. All right, that's that. We can go back to the player controller, and after we extend it from a player controller, we can say it is going to inventory interface. There we go. We have an inventory interface, and now that means we have to promise. We've made a promise. Now we need to extend, or rather, we have to implement that interface. So let's do that first. We're going to implement the interface. Another space there. All right, it's pretty. So with all of those, we're just returning things, right? Boop. There you go. We're going to make these in a second, but this inventory data map yanks our inventory data and returns it. Yeah? We're going to make these right now. This is going to be the delegate, so U property blueprint assignable that makes it so that we can bind things to this. Category equals inventory. This is an f on inventory item changed. On inventory item changed. So that's for blueprints, right? And now we need the native one. So this is for our item changed native, and this is on inventory item changed native. So that's where this is. So this is used for C++. This is our blueprint assignable one. And semicolon. Okay, and then let's make the other delegates real fast. uProperty blueprint assignable again. Category equals inventory. And this is our f on inventory loaded on inventory loaded. And then our native one is f on inventory loaded native, called on inventory loaded native. So there's that. I'm going to grab the comments because those are always good to have. There we go. Okay, everything's happy. Why is that squiggly? Oh, I know what I did wrong. Boop. Get inventory data map. Now it's happy. Okay. We now need to do a bunch of functions. First one, U function, blueprint implementable event. This is a category for inventory. And this is void inventory item changed. This is a bool. Have we added an item? And what item did we add? Or removed, thus the bool. Now we need to have a function which adds a new inventory item, and what are we going to call that? I wonder what we're going to call that. So blueprint callable category equals inventory again. This is a bool. Did we do it successfully? And we're going to add inventory item. We're going to receive an item, a new item. We're going to get the item count, and if we don't, it's by default 1. And we're going to get the item level, and if we don't, it's by default 1. What else do we need? That's it. That's the function. Okay, now the opposite of that is if we remove an item. So this is going to have the same header. I'm trying to do this quick so we can get to making this actually happen. But when you're coding, a lot of this code is, required? Duh. Removed item. So this is what we're taking away. Int 32. The remove count equals 1. We're taking just 1 away. Could technically not have to do that kind of stuff for just our coins, but in the off chance that we do want to do anything in the future, we want these functions. All right, now we need to get a getter. So this is get inventory items. This returns a T array of U hopper item pointers by reference, and these are the items. F primary asset type item type. So this will return all the inventory items. So this is an out parameter. So you're going to make a T array, and then you're going to pass it into this function, and it's going to fill that array of this item type. So you're saying I want these, and it's going to fill the array with all of them that it finds. Okay, next function. The reason really that I'm giving you all these functions that we're making all of this is because a lot of you probably have your own reasons that you want an inventory. So by doing all of this, you can figure out how to extend this in the way that you need. All right, inventory. It's going to return an int 32. It gets an inventory item count, so you can find out how many of this item do we have currently. Next one. Returns the item data associated with an item. Returns false if none found. So bool. Well, we actually need to... This is the same header I'm going to copy, paste. This returns a bool, not a vool, a bool. And this is get inventory item data. So this is not the full item, an array of them. We just want the data. So we're going to say this kind of item, I would like for you to fill an out parameter that I'm giving you called item data, and it's a const. Save inventory, load inventory, we're going to skip because I don't even have those. And then let's scroll down here, and protected section, we need some callbacks. So this is the notify inventory item changed callback, and we also need to have a notify inventory loaded. Do we really? I'm gonna leave it, but I don't think we use it. To the implementation. Whew, what a coding session so far, am I right? All right, here we actually do need to include core items, hopper item, not just the forward declaration. I'm going to go through and do my little thing, generate a definition, generate definition,
generate definition, generate definition, and generate definition. Oh, generate definition, generate definition.
I need to make a song. Generate definition, generate definition. All right. Bool, we're going to start with a changed bool and initialize it to false with an initialization list. If we do not have new item, which is a parameter being passed in, if it is a null pointer, we have a little warning here with my custom log. We're going to return false. Next, we're going to check, is the item count less than or equal to 0, or is the item level less than or equal to 0? Ha! I did. Item leave? No. We need item level. Let's go back over here. Yep. Item level. Okay. Again, my window got in the way that you cannot see my little cheat sheet here. And I'm just going to steal that and copy it so I don't have to type it out. Just some warning text that things went wrong, so return false again. Okay, so those are our checks out of the way. Now we need to find the current item data, which may be empty. We're going to make an item data of called old data, and we're going to call the item data function that we just made, and we're passing in the new item parameter. Do we have it? Do we have this item? Get the item data. And then we're going to find the modified data. So we're going to make another item data called new data. New data. Off the old data. Scanning for life forms. You little life forms. All right, new data. We're going to update the item data. This is, again, actually, this is off. We made this function on our item data class. So this is where we get to use it. So we're passing in a new one, again, off of item count. We're initializing item level. So we've just initialized a new item data that we're passing in as a parameter. We are going to pass in the max count and the new item max level. New data is being updated with a newly created item data from our passed in item count and item level. So we've initialized more, and then we are also updating it with the new items max count and max level. So that's what's going here. We're initializing this guy, right? And we're taking any of the other data that might be already in the inventory on that item. Okay, old data. If it is not equal to the new data, data. If the data has changed, we need to update storage and call the callback. So inventory data, we're going to add the new item that's being passed in. We're giving also the new data. So this is the map. So we have, what is that, key and value. So the new item's the key and the value is the new data. So notify inventory item changed. We're going to send true and new item in. And we'll change changed to true. Next, if changed is true, if anything, we're not doing this, but if anything changed, this is when you would write to the save game. So I'll just make a little note here in case someday we do that, and then we return true. If nothing has happened, if we didn't change, if this failed, if we didn't change, if this didn't happen, then we return false. We did not add anything. Whew, all right, how do we remove? You know what? If we don't have one, then we don't. And we return false. So we need to find the current item data, which may be empty. So what are we doing? We are doing another fhopper item data called the new data. We're going to get the inventory item data and try to fill based on the data of the removed item that we want to remove. So we're looking for that. And we need to check, did we find it? Wasn't found. If it wasn't found, we return false. Now if we did, if remove count is less than or equal to 0, we want to delete everything. So if the remove count was less than or equal to 0, new data.item count equals 0. We just destroyed them all. Gone. Else, new data.item count, we're going to do a little minus equals here, and we're going to remove away the remove count from it. Next, we're going to check if the item count, is it greater than 0 still? So we didn't delete everything. We want to update the data with the new count. So inventory data.add the removed item, and we pass in the new data. Otherwise, we want to remove the item entirely and make sure it is, we're not unslotting, so we don't need that comment. We don't slot anything with this tutorial, so we're removing the removed item entirely. We just remove it from the map. It's gone, right? Next, if we got this far, there is a change, so notify and save, but we're not saving. So notify inventory item changed. Again, we didn't add anything, so it's false, right? So, and then we say what we, removed item. And save inventory if we're doing that, and then we return true once done. So up here, we said yes, we added. So notify item, inventory item changed, true, we added something. Down here, in notify inventory item changed, we did not add something, false. Okay, now we need to do the getter. This is kind of just a for loop basically. So for const t pair, we're making a pair from the item as well as the fhopper item data. Pair inventory data if the pair.key f primary asset ID. We're initializing this with our keys get primary asset ID. All right, so we have a new asset ID initialized off of our key, which is the name, right? It's the hopper item. Sorry. All right, so we have an asset ID made off of the asset ID of the item, and now we need to filter based on the item type. So if our asset ID primary asset type is equal to the item type that's coming in, or our item type is not valid, items.add the key, right? So we're adding to this array, and we're filling it up, and we're filtering based on the item type. But if the item type is not valid, we're still adding the key anyway, right? Just in case. Just in case. I don't know why. Okay, get inventory item count, const f hopper item data pointer. The found item, we're just running a find algorithm on the item. If we found the item, we're just going to return found item count. If we didn't find it, 0. Easy enough. Alright, for getting the item data, it's pretty much the same thing. We're making a pointer called found item, and we're running the find algorithm again. And if we found the item, we are filling up that out parameter with the dereferenced found item and return true. Otherwise, we're going to make an empty data and send that out as well as return false. Last, we need to do our delegates down here, so we notify the native before the blueprint. So do the C++ one first. So inventory, on inventory, item changed native. We broadcast on that, and we pass the boolean as well as the item pointer. And then we do the blueprint. So item changed, broadcast the boolean as well as the item pointer. And then we call the BP update event. So inventory item changed event, pass again the bool and the item. Item changed, notify inventory loaded. Right. Okay, so we're not really using this, but we're gonna just stick it in here anyway. On inventory loaded native, because we made these, so we just need to call them. On inventory loaded, we're just broadcasting. That's all we're doing. Might come back and do all that. Okay, we did a begin play override, so we need to toss that in there too. This is where you would load the inventory off of the save game before starting, but we don't have that function, so this is where you would do that. I think we are ready to enter the editor, so I'm going to compile and see what happens. I forgot a semicolon. And player controller on this line right here, line 37, semicolon. Let's compile again. Real fast, I forgot another thing. In the hopper build.cs file, we need to actually uncomment this right here, slate and slate core, because we added an fslate style or whatever in one of our thingies. So make sure that that is uncommented, or you will be getting some errors. Back to the compile. Okay, I had a crash, so I think what you need to do is come over to your project directory and right-click on the U project and generate the project files in order to fix this. Then go ahead and reopen it. And let's compile again. Okay, and we're good to go. So in our top directory, we're in our blueprints. So we've got abilities, characters, and core here. We're going to make a new folder called pickups. And inside of pickups, we're going to make a new folder called tokens. And in there, we're going to make miscellaneous data asset. And this will be of our hopper token item. See, there it is, because we've created a data asset. So we're going to select that, and we're going to call this token underscore coin, I believe. Next, we're going to make a blueprint class, which is just an actor. Call it BP underscore hopper item underscore pickup underscore base. And off of that, we'll create a child, and this is going to be BP coin. Hopper item pickup base could actually go up to the pickups folder, fix redirectories. Okay. We're going to start with this hopper item pickup base. Okay, so this parent pickup is just your basic actor. It has nothing in here, so let's give it a variable called pickup type. And this is going to be of our hopper item data. Hopper item. There you go. And look at that. It allows us to now select a pickup type, and we have our token coin data asset that we've created off of our token. We're not going to do that here because this is just the parent. Let's also give it a count of just type integer, and it's going to have a 1 by default. We're going to want a player collecting, and that's going to be of type character so that we can store who is picking up this item. And a flipbook world location. This will make sense in a second. Make that into a vector and just compile and save. All right, so those are our 4 variables we need. Let's start creating the components to make this into a real world item. Okay, first we're going to add a capsule. This capsule guy is 120 for the X and for the half height and the radius. That's just from, again, the Action RPG. You could make that whatever you want. Next, we're going to give it a flipbook off the capsule. This is where we will be making, on the child class, the coin, or any child class, what it'll look like. And then off the flipbook, we're going to add a light, point light. This point light intensity is going to be set to 20,000. The attenuation radius is 250. And last, we want to add on the capsule a sphere collision, and this is our pickup collision. And this is going to be set to 75. So that's the collision in order to actually pick up this item. We want to set that to overlap only pawn. Let's go to the event graph and actually make some logic in here. We're going to grab this pickup collision and go to on component begin overlap. The other actor we're going to check has tag. And we're going to look for player and a branch. We're going to add that tag to our player character. So that's what it's looking for. So this cannot be picked up by an enemy type. We're going to take that, we're going to cast to a character, true, and then as character we're going to set the player collecting. Next, if we are collecting, we want to turn off our pickup collisions, so set collision enabled and set no collision, because if you don't do this, you're going to collect this multiple times into your inventory, and we don't want that. Okay, next we're going to want to call a custom event, so this is going to be called give item. And we're going to call it here, give item. We're going to check if the player collecting is valid. If the player collecting is true, we want to get the controller, cast to our hopper player controller. And from that, we want to add inventory item. There we go. The item type is right here, our pickup type. And our count is our count. You know what? I'm going to rename pickup type to item type because that makes much more sense and is clearer. And then we're going to also have another custom event called animate pickup. And we're going to call animate pickup right here. Because we want it to do something when we pick it up. And then you would do a play sound right here, but I'm not doing sound at the moment, but this is where you would also call that function. Real fast, because we're also network, go ahead and replicates, click that on, because that's going to be important. All right, we're going to animate the pickup so that it kind of pulls towards the actor who's picking it up, so it goes whoop into their body as well as shrinks as it comes into them before it destroys itself. We're going to get the paper flip books, get world location, and we're going to set our flipbook world location to that. We're going to make a new timeline. I'm going to rename that. We want it to be called animate, so go ahead and open that too. We're going to add a new float track. We're going to add a curve at 0, 0. We're going to add a curve at 0.25 after a quarter of a second at 1. I'm going to hit both of these to match it in here. Name this as alpha, and then right click here, and we want to do an user, and right click this and we'll go user. Bring that down so it's parallel. Bring that to about there. So we have this little kind of a curve here. Let's go back to the event graph. What we're going to do is we're going to set relative scale 3D on the update here for the paper flipbook. We're going to take that and then get world scale. We're going to take that return value and we're going to lerp the vector with this alpha to 0, 0, 0 and put that there. So it shrinks as this timeline goes along. The flipbook scale is going to lerp itself towards 0. After we set the relative scale 3D, we want to set the world location, and we're going to lerp that as well. We're going to grab this variable which we set. That's why we have it. We're going to lerp using this alpha again. However, we don't want to go to 0, 0, 0. We want to grab our player collecting, and we want to get actor location. So we're going to lerp ourselves over to the collecting player and then pass that there and teleport. When we're finished, we now want to destroy actor. Okay, that is all the functionality that we need in our parent pickup item. Go to your BP coin, the child class, open up the flip book. We're going to add the coin, and I'm going to put my special face camera material on it, and I'm going to scale this guy up to 5. So there's my coin, and it has my special material, so it's always facing the camera. And I'm going to change the light color also to kind of a yellow coin color. Now if I drop these into the world, I have coins. But we also want to make sure that we go to our item type and we set it to our token coin asset. Hit save. Count is value of 1. And before we forget, we need to go to our player character. We need to search in the details for tag. We want to add player, because if you remember, in our functionality, we are searching for that tag before we can pick up. Come over to your maps and modes in your project settings and make sure your player controller class is set to our hopper player controller. Hey, I'm wearing a sweatshirt now because I'm coming in to fix the end of my video that I realized while I was editing. There was something I forgot. So if we go to the animate timeline here, length 5, that actually needs to be set to 0.25. Otherwise it's going to take 5 seconds before this timeline finishes and destroy actor is called. So once we have that and we come back over to test and we hit play, there we go. We collect all the coins and they disappear. Hello everybody. Yet again, I come to you in a new shirt because this is another addendum to add to the video the next morning because I love you guys just so much. I realize I didn't prove that this is actually in the inventory, so we're going to do that real fast. We go down and find ourselves our player controller here. I'm going to lock it. You can see inventory data with a map elements right there. If we come back in here and collect our coins, hit F8 to get my mouse back, look at that. We have the token coin, item count 3, item level 1. So we now have 3 coins in our inventory, just to prove that all that coding work does something. So there you have it. That's how you collect coins. I know it's a really long video. I think next time I'll go into setting up a UI so you can see how many coins you've collected or something. That'll be way shorter. Thanks for sticking with me. Have a fantastic week. So I was editing this video and I realized I never actually opened up the token coin data asset, which really didn't matter in this video, but it does matter for you and for the future. This is where those things that we created, all the variables, here's our item type, token by default because this is a token. Item name, this is where we could do coin. Item description, this is a shiny coin. Item icon, if we had an image, I don't think... Oh, we do. All right, so yeah, there. We can add that sprite in there. Size 16 by 16. So there you go. That item icon can be in there. The price